ceramic and one probe to the piece of metal and check on the multimeter, see if the reading is open line, like this. Now it's open line. If you get reading like this multimeter now, if it gives you some reading, it shows your wiring is not good, like some part of your band element is leaking electricity. So you have to recheck and make sure every time your reading is open line. A nylon screw is used for housing the band element. Like this small piece, the band element is housed inside the nylon screw, and outside the band element there are some epoxy, and usually after you apply the epoxy you have to wait for 24 hours to let it get hardened and let it completely dry, so that your band element can permanently stay inside the nylon screw. Till now, we have finished making a bender element, and in the rest of the radio, I will show you how to perform a bender element test. In order to perform the bender element test, we need some different equipments, like those equipments you see here. We need a function generator or wave generator, like this one. It can generate different kind of waves, like sinusoidal wave, square wave, and other different types. You can change the amplitude, the frequency, the input phase, the starting angle of the input wave. And we need a amplifier, because the generator usually generates very weak signal. We have to amplify the input signal. And of course, we also need a filter to filter the noisy of the transmitting signal. And also we need a oscilloscope. The oscilloscope is to show the wave, the input wave and the received wave on this screen. Now I will do a quick calibrating of the bender element. First, let's adjust the function generator. I will use the sinusoidal wave and put it to the burst and hook up the bender element to the function generator as shown here. And for the other bender element is the receiver. It is hooked up to the filter, and then the filter hooked up to the oscilloscope. And here I put a low pass filter for 10 kHz, and the second channel I put a high pass filter, and the input wave is 5 kHz and the amplitude is 10 volts. The soil sample here is a EPS modified kaolin light soil, and you can see one side I push the bender element inside the soil as a transmitting sensor. This side I push in the bender element as a receiver, and both the transmitting signal and the received signal will be showed up on the oscilloscope screen. Now I push the triggering button. Both the two signals will be showed up on the oscilloscope. Let's start. Okay, so the first wave is the input wave. It's a sinusoidal wave, and it's moving up and down. This channel is the received signal. There is a time difference between the received signal and the input signal. Like now, I put the cursor on the starting point of the input signal. We put it as x1. And like the cursor is moving, we now do a quick calculating. I will use this point as the start point of the received signal. Let's make it as x2. And now you can see delta x is minus 426 microsecond. You can measure the length of the sample and then divide it by the time. This will give you the shear wave velocity of this sample. And you can compare the shear wave velocity you calculated from this sample and compare with the literature results. To design and perform a bender element test is almost finished till here. But for your research of a bender element test is far away. We can put the bender element into a triaxial compression test system. We can put it into a consolidation system and also to a unsaturated soil testing system. So the bender element test can be used together with many soil testing systems to test the shear wave velocity under different loading conditions. And I hope this entry-level video of the bender element test can help your research, and thank you very much for enjoying this video. This video is made by students, not an official publication for the university, and I hope everyone can enjoy. Thank you.